Welcome to Walk About the Galaxy, the springtime astronomy podcast, where the science is universal, the opinions are personal, and the hosts are practicing astrophysicists at the University of Central Florida, where there's a lot of S.
It's a hard
a lot
word.
of civil
It's a hard
in
word.
there. We are Strange Charm atop the Astroquarks, also known as Josh Caldwell,
Addie Dove.
And Jim Cooney.
coming to you from the satellite Walkabout studio. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms, including YouTube, where you can see our music video and fine actors who portray us. On this episode, we are played by Hugh Jackman.
Lucy Lawless.
And Dolph Lundgren.
Uh-oh.
Yeah.
That means Jim's got some whoop ass he's preparing.
Oh, yeah.
He's preparing.
The very
to unleash,
underrated
although
Dolph Lundgren.
Hugh Jackman is a jacked man.
That's true. It's hard to beat up Wolverine.
Yeah. Our stumpers today are re-entry related.
Okay.
Okay.
I think we may have-
or something like that.
We're re-entering.
That's not a word.
Oh,
We're
sorry.
re-entering the world.
We are re-entering the world. So I'll pretend that that's why they're re-entry related.
Perfect.
I think we might have done something along those lines before, but Addie, splashdown or dust down?
Oh man. Usually just call it like a land. I like to call it a land landing.
Land landing or a sea landing?
So typically a splashdown is gentler.
Is it?
For the landings?
I would
Yes.
assume so, but I don't know.
Yes, they're typically more gentle. If you look at like the Soyuz landings, those things come in pretty hot, and apparently it's not super pleasant. But if you look at like the blue capsule, the suborbital one,
Right.
they've been landing it nice and gently. It makes a big dust up, but it's just because it's in the desert.
And also they do a little
They do a little
gas right beforehand
Yeah, so
to
they
sort of
don't hit
soften the
quite
blow a
as
little
hard.
bit.
Yeah. And I feel like land landings typically are actually easier on systems because when you land in the water, you have to worry about salt water and all that crap, right?
Yeah. The other thing I would worry about with sea landing, or
Sinking.
a seeing, an oceaning, a
Yeah.
watering, well, it's beyond sinking, is sea sickening.
Oh, I mean, you've just been in space.
I
think
know.
That's not the most thing
I don't know
worry
though.
about.
I don't know.
I guess so. We have lost capsules in the ocean before.
Yeah.
We have?
Yeah. Gus
It was
Grissom's
Mercury.
Liberty Bell 7,
Yeah.
the Mercury program, was lost, and we recovered it and was restored at the Kansas Cosmosphere and Space Center.
Like lost
It
after they got him out.
It sank.
Yeah, but it
He
was,
barely got out.
He barely got out.
It was dicey.
It was a little bit of a not the greatest re-entry and splashing situation. Yeah, it was kind of, there was a lot of finger pointing and
That would be a big giant letdown to like make it up to space, back down to space. Now you're on the Earth, and then you die sinking in a. Oh,
Yeah.
oh,
Yeah.
man.
Although we've only lost astronauts in the atmosphere.
Yeah,
The
that's
U.S.
true.
has only
Right.
lost astronauts.
Yeah.
Well, that's I guess that's the dangerous place.
Yeah, the transitions.
Yeah.
are
But the
dangerous part.
astronauts used to have to carry like a gun and a bunch of other stuff, and that was actually for like the landings or the aborts and stuff in case they landed somewhere weird.
Somewhere where there's a
Right.
war going on.
Or like
something
a bear, I
that.
think.
Or a bear.
But I guess so. I would choose land landing. 'Cause
Okay.
It's fun to say with the asterisk that it's like a Blue Origin style. Not
Blue
a,
Origin
I don't want to
landing.
land in a Soyuz.
Not a Soyuz
I
landing.
mean, I would if I had to. If that was my only option.
Yeah,
Obs.
those are super cramped.
There was a funny post from.
Because one just came down today, right? Or it's on its way down.
It's on
Soyuz.
its way. I
Yeah.
don't know if it landed or not.
Yeah.
There was a funny post though recently, that, like did a counterpoint of the Soyuz capsule and the Dragon capsule, and like the interior roominess or
Oh.
lack thereof.
Yeah,
Soyuzes are so tight.
very tight. It's a
Soyuz
much
okay?
smaller rocket than.
Yeah,
Yeah.
and it's a very small capsule and it's a very tight space.
Yeah.
They're cozy in there. You would not want to spend so. I'm sure they're super happy they're making it up there in like 3 hours now.
Right.
Like,
Yes.
you
You don't
don't
want
have
to
to spend much time in this thing.
hang out in that for a long time. Well, Jim, slightly different take on it. Parachutes or wings?
Parachutes.
Okay.
Parachutes. I feel safer.
The parachutes do have to deploy and
That's
open
true.
up, and the wing is just there,
I guess that's true.
or at least for the
Unless it
shuttle,
breaks off.
it was there.
Yeah.
I'm not trying to talk you into it out of anything. I'm just pointing
Parachutes
out
are
that it's
fun.
maybe not as obvious.
I just would enjoy a parachute I mean, like once the parachute has deployed, I would be very nervous before that. But once it's deployed, it seems like a really fun trip down.
Have you ever done like the boat
No.
parachuting? What's that called?
I know what you're talking about, where they like
Parasailing?
drag a, yeah, something like that. Where they
I've done
drag
it.
it, yeah.
Yeah, you get like dragged behind and then you're in a little parachute. And
Yes.
you loft it up.
I've seen that.
And have you ever done skydiving?
No, come on,
Both are amazing.
ludicrous.
Planes are not made to be jumped out of.
No,
So then I think you prefer wings.
skydiving is
Wings.
stupid.
I
What?
think you actually
Do I prefer wings? I'm like,
Maybe you do.
all I know is either way, you're coming in really hot. Well, anyway,
You are.
Yeah. So
They're coming in fast. It's true that there was the reentry catastrophe with Space Shuttle,
yeah.
and there hasn't been a parachute.
There's been a couple of parachute
Re-entry.
failures, but we have multiples, and so they haven't
Right.
had any significant effects.
Yeah. Okay. Well, today we're not talking about any of that stuff. Well, we'll talk about space news stuff, which relates to that and relates to landing, in particular landing on the moon, which we will talk about some updates on that, but also scintillations from distant galaxies and dust from above. But first, this episode of Walk About the Galaxy is brought to you by Electronic Band Structure. We like to go by EBS, and we have the best new technopop sound. Get our new album with hits including the timeless Somewhere Over the Band Gap, the nostalgic I'm Picking Up Lattice Vibrations, Electronic Excitations, rock anthems, In the Name of Fermi, Conduct in the Name of Fermi, folk music, Like a Bridge Over Atomic Orbitals, I Will Jump the Gap. Don't worry, we're almost done.
Is there gonna be a
Political. And here's to you, Erwin Schrödinger. Einstein never loved your paradox.
Oh.
Whoa, whoa, whoa. Go save your cat, Erwin Schrödinger. Measurements are meant to save the day. Hey, hey, hey. Hey, hey, hey. And last but not least, for the pure hard rockers, I love electron holes. Move that charge one lattice over. I love electron holes. Put another charge in that crystal, babe. All these and many more available on the new EBS album, Professor Fermi's Lonely Valence Band.
Oh.
Electronic band structure, ideas for life.
Wow.
Very clever. Somebody has to get him a job that takes more time.
Our sponsor, maybe?
Yeah.
Electronic band
Well,
structure?
Yeah.
Electronic
Yeah, the
band
publicist
structure,
for electronic band structure needs, yeah.
Yeah.
ideas for life.
I was shocked that there was no jazz songs in there.
Electronic
I was
band
not
structure,
shocked.
you were not shocked.
I was not shocked.
Maybe somewhere over the band gap is sort of would that qualify as a jazz standard?
No.
Okay, I don't know. There's like two flavors of jazz. There's some jazz that actually sounds like songs, and then there's some that's
We've had
random
jazz
notes.
debates before. I didn't actually need to have that. So,
Okay,
what was the phrase?
GE.
ideas for life. Jim goes with GE.
I know this one, but I don't know it. I can't think of it off the top of my head. I think it is. I don't know. IBM.
GE is the right. You're on the right track. Panasonic. Yeah. Anyway, electronic band structure. What does BTS stand for?
I don't actually know.
BTS?
They're like the #1 band in the universe right
Yeah.
now.
Oh, yeah, I don't know.
Never even heard of them before.
That's a K-pop band, yeah?
It is,
Yeah.
Yeah.
I think it's a Korean name that I,
I think
can't
it's
pronounce.
I think it's Korean for electronic band structure.
I don't, but
No.
Yeah, when you said BTS, I was thinking, is this a physics thing that I'm not affiliated
Right.
with? What is he talking about? Yeah.
yeah, it's a Korean name that I can't
okay.
pronounce.
So it's not actually BTS. It's like square, triangle, little person drawing or something like that.
There are many of
Those things in there.
characters, and then there is
Circles
an English translation,
Okay.
something like
So we have-
Plankton.
there's some human space flight exploration news.
There's a bunch of stuff. Yeah, I think we talked last time about the rotating crews on orbit.
Right.
We already mentioned that. Shannon Walker actually is commander of the space station for like a few days.
She's an old timer.
Veteran NASA astronaut. She's
Right.
been up a bunch. Yeah, so that's kind of exciting.
The next Crew Dragon is slated for next week.
Next week.
The week that this will be out.
Yeah, stupidly early in the morning.
With
Unfortunately.
4 people going up. And when they do, there will be 11 people on the space station, which will be the most since the end of the shuttle.
Yeah, they need more bunk beds.
Yeah.
Up there. And the other big news today was sort of a surprise announcement.
It was.
There hadn't really been a lot of press about it because they hadn't. I think it was a surprise announcement, and it leaked that NASA selected SpaceX for the Human Landing System, which is the name for the landing system that will put astronauts on the moon.
So this is interesting on a couple of levels. So one is NASA's building the Space Launch System.
Yes.
And they're building the capsule that goes on the Space Launch System that takes astronauts to lunar orbit, basically. But
Yeah.
they're contracting out the job of getting those astronauts from lunar orbit down to the surface of the moon.
Yeah, so it's this weird new, well, I don't know, interesting new architecture, right, where NASA has been contracting out a lot of these things, and including, so the thing that is going to be orbiting the moon in theory is called Gateway, and the idea of Gateway is it's like a little docking port for now. It had grander schemes.
Right.
So right now it's
It's sort of like a phone booth.
It's a propulsion module and like a docking ring and a couple of other things. It's
Yeah.
a really bare bones, or it will be. But that's been contracted out, and so yeah, so like NASA will take them
I didn't
up.
know Gateway had been contracted. So
Yeah,
that's
so Maxar is the
Okay.
propulsion element, and somebody else is another element.
So it's basically it's like a meeting room. So
Yeah.
NASA's capsule will go to Gateway orbiting the moon and dock to it,
Yeah,
and at the other end of that room will be
another
the
docking
lander,
ring or something where the lander
the
is
thing
docked.
that, and then they'll just sort of crawl through from one end to the other.
Yeah.
And the announcement today was for that lander.
Yeah, and the 3 companies that had already been sort of pre-selected and were in like a phase A or something, I don't know, an early studies kind of thing, were SpaceX with their Starship lander, Blue Origin has their national team, so it was like Blue Origin, Northrop Grumman, Lockheed collaboration,
Yeah.
and then somebody else collaboration.
Some of the big
big
old names in
Yeah.
U.S. aerospace.
But like organized under the label of Blue, which was
Right.
pretty interesting. And then Dynetics was the other one, and they had, and both Blue and Dynetics had sort of a more traditional lander, kind of what you think of when you think of like the lunar element, the
Right.
lunar landing module, where it's like a lander system, got some legs. Got
Looks
sort
a
of
little bit
module.
like the Apollo one on
Yeah.
steroids,
Yeah,
kind of
yeah, they were way
serious
bigger.
steroids.
They were way bigger than the Apollo ones.
Yeah.
So,
But SpaceX, so they down selected today, sort of a surprise announcement to only SpaceX.
SpaceX.
It had been expected that they would down select from 3 to 2
Yeah.
for sort of further development because
That's what they've been doing for a lot of them recently.
Right.
So Elon Musk beat out L. Ron Hubbard. That's pretty great.
Are you calling Jeff Bezos L. Ron Hubbard?
No, that last company
Dynetics?
Dynetics. founded by L. Ron Hubbard.
Dianetics.
Oh, different. Okay,
Yeah.
I'm stupid.
I love it.
Okay, but also
I love it.
yes. So they're
Who knows,
NASA's.
though, maybe.
It seems like NASA's kind of put all their eggs in the SpaceX
Yeah, I
basket.
kind of hate that.
And the vehicle is basically the Starship vehicle that we've been having such great fun watching blow up recently.
So why do you hate the fact that it's all SpaceX?
I think that like what NASA's been doing a lot recently is just, as we said, like down selecting or selecting a couple of companies and sort of having that competition. And so that's been the case for the capsules to get to the ISS even, right? So SpaceX has done really well with that, Boeing a little bit behind, but there's still been 2 companies that they've been working with to like get crew up there. I think I don't know,
It's a risk mitigation for sure,
Yeah.
right? This is something that's never been done before.
Yeah.
It's a very complex system.
And like, I guess SpaceX is the only company right now, well, of those really, that has like a track record of putting humans into space now.
That's true.
But like, this isn't the putting humans into space part, it's the
Right.
landing them on the moon part. Like, it's so different that I thought that like having a different company sort of do that element would be
Yeah.
interesting. But we saw something that like the SpaceX did was way under the other ones.
Mm-hmm.
Yeah.
So I'm sure that played a
The
role.
low bid is not always the best bid, though.
Yeah.
When I'm contracting homework, I usually do not
Not
go with the
necessarily
lowest
with the
bid
lowest
because
bid,
that means they're going to
right.
do a crap job.
Yeah.
Now, I don't think SpaceX will do a crap job, but
No.
Well, it'll be interesting to see because like you said, the Blue Origin national team model with Lockmart and everybody, you have this sort of lower part that's got, spidery legs, and then there's the ascent module to get them back up. So the whole thing you land somewhat like the Apollo mission. A big unit lands, but only the top half of that unit takes the astronauts back up to the gateway. The Starship model from SpaceX, it's this Flash Gordon stainless steel rocket, and the whole thing comes down, and then the whole thing goes back up again, and it's a very different kind of architecture.
Yeah.
One of the things you were asking, Maddie, was how long's the ladder to get the astronauts down from there to the surface of the moon?
Because Starship, I mean, we've seen Starship, if you've watched any of the videos, like the little part of Starship that's the big giant steel cylinder crashing into the pad. Before it crashes, you're like, oh, that's a really tall thing. When it's sitting on the pad, you're like, oh, that's a really tall thing. And they're like, I've never seen any diagrams of like how the astronauts get out of that
Egress,
thing into the ground, onto the ground.
Well, so speaking of the Starship, they're skipping serial numbers 12 through 14 apparently, because we saw SNs 9, 10, and 11, serial numbers 9, 10, 11 for the SpaceX Starship do these little suborbital test flights where they, came close to nailing the landing. And now they're doing SN15, which I guess has some upgrades. It's not just a copy with some different software and hoping for a better outcome. So that's, I think, been rolled out. So it'll be interesting to see that. And of course, the one that they're proposing for the moon, I'm sure, is not going to be just like the ones that we've been seeing do these test things.
Hopefully not. I'm guessing the leak had something to do with the Rush announcement. I think that it wasn't supposed to be announced.
I see.
Because usually a Friday, like something like this, they would do a big press thing.
Not Friday at 4 p.m.
Usually the Friday at 4 p.m. announcements are like the ones that are sort of like,
we don't want anybody talking about it.
Yeah.
Well, speaking of Blue Origin landing, they had a suborbital flight recently of their New Shepard vehicle, the version that's going to carry people up.
Yes, soon.
Right.
Hopefully.
Sounds like the next flight.
Yeah.
So tweets from Jeff Bezos indicated that the next one will have people in it.
Maybe 3 months, I guess. That's how long it's been since the last one.
Yeah.
Maybe less. Probably 3 months.
Yeah.
This summer.
So we don't know who it'll be, but probably employees of Blue or something like that.
Yeah, this one was fun. They had a dress rehearsal of like astronauts getting into the capsule on the pad. And then they did a comms check and then they got out.
Yeah.
Astronaut stand-ins, they called them.
Yeah.
And then Mannequin Skywalker flew. So this is
Right.
their mannequin that flies with the flight. And then they did like some practicing egress stuff at the landing site too.
Right. After it landed, they put the astronauts in, and that's okay now.
Or maybe they flew them. I'm just kidding.
Yeah. So that's exciting. Well, we've got a science topic, we've got a dust topic, and a sort of dark matter-ish kind of topic, or a missing matter topic.
No.
I'm not sure if it's dark matter or not. But we also have bonus trivia. It's a super special episode today.
Wow.
I should have said that right at the top, because now everybody stopped listening. It's a super special
Maybe
episode.
they'll tune back in right now.
So we have regular trivia and also Top Quark trivia. So since we've got extra trivia, why don't we do one of them now?
Okay.
And we'll do our first science, then we'll do our other trivia.
Okay, this is totally off topic, but this was something I was thinking about the other day.
Okay.
This is the fun astronomy podcast, not the fun math podcast, but we're going to do a fun
Sometimes
math.
But you know what our undergraduates find out when they take astronomy?
Yeah,
math
it turns
involved.
out there's a lot of math involved.
Yes.
All right, so 2 fun facts that you definitely know. And by the way, you guys may just know the answer to this right off the bat, but I don't know that all our listeners will, and so we're going to find out.
Okay.
And maybe you don't. 2 fun facts that everybody knows. If you take any number and raise it to the 0th power, you get
1.
1.
If you take 0 and raise it to any power, you get
1.
0.
0. So
Trick!
So then the question for you will be, and you have 4 choices. What is 0 to the 0th power?
Oh.
Your choices are 1, 0, 1/2, or undefined. So just mull that over until the end of the episode.
Interesting.
Okay.
0 to the 0th power. Which of those 2 rules does it obey, or neither?
Okay. The half is a weird.
It's got a spin transition thing going on there.
This may be some sort of psych out.
Yeah.
I don't know. All right. Well, while we're pondering that, and I'm pondering why I thought 0 to any power was 1.
1.
You're just locked in.
1.
That
I was
answer.
locked into 1.
You're just
Yeah.
locked in.
I was just sure that whatever he's going to say next was the answer was going to be 1.
Yeah, yeah.
So that's probably going to be my answer to the trivia.
Got it.
But in any event, let's talk astronomy.
All right,
What?
let's do it.
Okay.
There's something about scintillating galaxies.
I love that word.
Scintillation.
Scintillation.
Scintillation. Yeah, really cool. This was a cool thing where,
What is scintillation?
so this is really just like twinkling, the twinkling of a star, right? So when you look up at the night sky, stars twinkle, and that's really pretty and nice and romantic. But it's awful, of course, for astronomers.
I hate that.
That the twinkling of stars, because it's really the light from the star getting pushed around by moving atmosphere, right? The atmosphere is constantly rising and falling and moving left and right and this and those and it's in a very random way.
And it's like a lens. The atmosphere.
That's right. The different layers of the atmosphere have different densities, and therefore, as light goes from one to the other, it
It's turning left and right.
it refracts,
Zigging and zagging.
right?
To and fro.
Which basically serves to smear the light out from the star, and that stinks for us on Earth, which is one reason why a space telescope is so groovy. You don't have to deal with that.
Although there is like scintillation that like people at Arecibo use, like interplanetary scintillation to look at like other stuff in between us and stars.
Oh, well, there you go.
Well, why don't you just ruin the whole thing?
Oh, no, sorry.
Exactly. So that's what this is the bad scintillation, is the twinkling of stars.
I did not read the article.
Good. Jeez.
Spoiler alert.
Yeah, whoops. The good kind of scintillation is that allows us to determine what's between us and some other bright thing. So this was.
People also get mad at that dust.
That's right.
Sure, it depends on what you're trying to study,
Well,
right?
when I was in grad school in astrophysics, we had a class on stars, and it was all about, the horrible interstellar medium that's ruining our view of the stars.
Right,
And
so it
then-
depends on whether you're studying the
Right.
stars or the interstellar
And
medium.
then there was another class on the interstellar medium, and they're like, so there are these stars, we don't really care about them, but they light up the interstellar medium. Look at all this interesting stuff we can learn.
Exactly.
Yeah.
So this new thing is using a cool telescope in Australia, or an array of telescopes, which has the awesome name ASCAP. I'm gonna put a cap in
Probably
your
supposed
ass.
to put an emphasis on a different part of that.
It's ASCAP.
Title of the episode.
Yeah. Which stands for the Australian Square Kilometre Array Pathfinder,
Yes.
which I don't know if that really flows, but ASCAP is cool. But anyway, it's a bunch of radio telescopes. Anyway, they're looking at very distant things. Specifically, they're looking at quasars, these very distant, very bright objects that are basically, the active centers of distant galaxies, and looking at a huge number of them. And it turns out that some small fraction of them scintillate. So that is, they twinkle like stars.
Even independent
Independent of the atmosphere. This has nothing to do with our atmosphere, right? So, but it does have to do with that light passing through something. And the nice thing is, it's enabling us to see this stuff that we otherwise couldn't see. This stuff is very, very cold plasma. So the thing is, we know roughly kind of how much stuff there should be out there compared to how many stars there should be. So that is, in our galaxy, in the Milky Way, we know kind of how much baryonic stuff, that is normal matter, there should be, and we can't see it all. And we can see the hot gas, and we can see the stars, of course, but cold gas is very, very hard to see. One way to find it might be this method. So that looking at this thing, this survey found this really cool tendril of this very dark stuff. That is, they saw six, maybe it was five. 6. They saw 5. I think they saw 6
One.
total. Anyway, they saw 5 or 6 of these scintillating things, and they were lined up.
Ooh.
I think they saw 6 of them, and 5 of them were like lined up in this one line in the
Okay.
sky.
They saw other stars nearby that weren't scintillating.
Right.
Scintillating.
Not stars, but yeah, these
Spots.
distant quasars, galaxies that weren't scintillating,
So
and
you're
then
saying there are 5 lights? Because I'm pretty sure
There's 6.
there are 4 lights.
no, I'm telling you, Josh, there are 5 lights.
5 lights.
You'll learn to accept it.
Episode title.
Start, there are
But,
5 lights.
But anyway, this is a cool new way of like finding stuff. Is by
Yeah.
looking at huge numbers of these distant galaxies and finding ones that scintillate. Usually, one isn't going to tell you very much, but if you have
5 in a row.
5 in a row, then you found this cool
Bingo.
filament
Thing
of
that's
stuff.
bigger, right.
That too.
Now there is something. Eddie's a plasma expert, and you're just an all-around smart guy. So I didn't understand one part of this this thing as I read it. It's supposed to be. So the idea is it doesn't glow. The reason you can't see this dust
Right.
is because it's very, very cold, right? And cold
Mhm.
things don't let off very much radiation, and the stuff they does isn't easily visible. But then it also said it's plasma. Cold stuff shouldn't be a plasma.
Can.
So that's my question: is what up?
Well, they talk about cold plasmas and hot plasmas, so it's all cold is a relative term. I think is the only thing that's up with that.
Well,
Did they give a temperature?
No.
So there's a difference between a kinetic temperature and a plasma temperature.
Gosh.
Right. So plasma temperature refers to like the energy of the electrons. So like a plasma temperature is often on the order of like 1,000 Kelvin or something like that. But like if you were to touch something that had that plasma in it, wouldn't feel like 1,000 Kelvin.
Right.
So your electrons can have a lot of energy, but it can still have a low thermal temperature. So that could be what the discrepancy is.
I'm not sure I understand that, but that's just because I'm stupid
No.
as far as plasma.
It might not be just because you're stupid.
Yeah. Yeah, I mean, the point was the reason this upset me is like you can't see this stuff, so it's obviously it's cold,
Mhm.
but also it's not emitting or absorbing very much, right? And that's largely because its electrons are stripped away from its
Right.
atoms,
That's
which
why
means
it's a
you're not
plasma.
having
It's a
electrons. Right,
plasma.
exactly.
So what you're asking
Which
is
is-
how come it's a plasma and not recombining?
Right,
Right.
that's right. If it's so cold, usually that means that things recombine.
Usually there's some energy source that keeps things in an ionized
Right.
state.
Mhm.
Right.
I see the problem.
And so I would have to know what the particulars of this
Yeah, I don't- yeah. Me too. Probably should.
plasma are to have any idea about that.
Yeah.
I do know that like when we're talking about different plasma populations in the magnetospheres of the giant planets in our solar system,
As we
for
often do.
example,
Mm-hmm.
there's like the Van Allen radiation belts. It's trapped charged particles in the Earth's magnetic field. So all the planets with magnetic fields have plasma populations in them. Like in
Mhm.
Jupiter, the volcanoes of Io
Mm.
feed material
Yeah.
into Jupiter's magnetosphere where it gets ionized and by sunlight.
Mhm.
So that's the sort of energy source that's creating these things as ions. And once they're ionized, they're traveling along the magnetic field lines very different ways.
Mhm.
Is it low enough density that it's like
There's
Not
there's
likely to
some there's going to
recombine?
be some recombination time, and
Yeah.
there's some ionization time scale.
Hmm.
And in those various populations, sometimes we talk about the cold electrons and the hot electrons.
Oh.
It's like guys, it's like these are like KeV electrons.
Oh man,
or
we're getting down a rabbit hole.
eV
Yeah, I
things like
guess.
that. So that I'm trying to distract from the fact that I don't really know the answer.
Right. None of us really know the answer. That's okay. But
we could just call it a gas? How
But
about
it's a
that?
cold plasma.
but we found a way to see it, right?
It's pretty
by,
cool.
by looking at
And so why are we excited about that?
well, just because it's a way to find this missing matter. It's not dark matter exactly, although you could group it. I mean, dark matter you might
It's
call
unseen.
anything that I can't see,
Right.
but it's very different from the dark matter that we know is some weird new particle.
Because this matter is baryonic.
It's right. It's regular stuff. It's protons, neutrons, electrons. It's regular stuff, but it's just very cold and so hard to see. But here's a way to find it, which is kind of a new, fun, novel.
Scintillation of quasars. And so the ASCAP, I'm going to definitely have to say that a lot. That's a radio telescope.
Right. That's an array of radio telescopes out in Australia.
Okay.
Exactly. So, that stared at one big patch of sky for like 10 hours at a time, and it did it many times, 10 times over, or something like that, over the course of a year or a couple of years. I mean, you do need this, you know, in the atmosphere, the time it takes the light to dance around is very short, right? These are fractions of a second it takes for a big cloud of gas out or plasma out in the universe. Of course, the times are longer, so we're talking hours.
So it's like a super, super, super slow motion twinkle.
Right, exactly.
Okay.
So if you looked at it just over the course of a minute, it wouldn't change, you wouldn't see the twinkling. But if you look at it over the course of 10 hours and look over that many times, then you can watch it twinkle. It's a slow twinkle, exactly.
Right. So the radio telescope is actually able to see the position or brightness distribution of these things shift a little bit.
Yep.
Interesting.
Yep. Pretty cool. Pretty cool.
Scintillation is cool.
Yeah, and I agree. Awesome word.
It's scintillating. Study.
It'd be a good name for a rock band.
Scintillation.
Scintillation.
At least a song.
Okay. We can go straight. I think maybe I should use the second trivia as the segue into our second
We're
topic.
going to answer our first
But
trivia.
maybe we should answer the first trivia,
All right.
Okay.
then segue over. So
Okay.
0 to the power
Zero
of
to the power of 0. Should be 0, should be 1. Which one is it, or is
Is
it
it
neither
neither?
one?
You said 0, 1, a half, or undefined.
Correct. Those are your 4 options.
So I want to ask, where would that come up?
Yeah, not. I can't see any astronomical context where that would come up, but
In a mathematical journal.
it's just an
On an
interesting
exam.
question.
Yeah. Okay.
It's just
Or
a mathematical
walkabout
interest.
trivia question.
Yeah.
Yeah.
Okay.
There's lots of weird mathematical oddities.
Yeah.
0 to the power of 0. I'm going to say
There's some good YouTube channels.
1.
Josh says 1
I'm
because
going
he's
to say
stuck on that.
undefined.
You can say undefined. The
But
answer
I wanted
is.
to say 1/2.
You wanted to say 1? I hear you. The correct answer, Josh, is right. It is 1.
Oh.
It is in fact 1.
So that takes precedent.
The power.
It's weird, and it's you could, of course, we could prove this if we sat down with a piece of paper and whatever. We're not going to do that
Just
obviously
write a
on a
bunch of zeros.
podcast, but you can prove this to yourself, or not maybe prove it, but you can convince yourself of this just by getting your calculator out and doing this fun thing where you do take 1 to the 1 to the power 1 and put it in your calculator. Of course, gives you 1. Then take 0.9 to the 0.9 and put it into your calculator and see what you get, and then 0.8 to the 0.8 and see what you get. And what you're going to see is this really interesting thing. It starts out at 1, and then it starts to go down, and you're like, oh, it's getting smaller. 0.9 to the 0.9 is smaller than 1.
Right.
And you're like, oh, it's going to go down to 0. It's 0.
But once
Keep
you get
doing that. It
half-
hits a point,
Yeah.
and then it goes back up.
Right.
And so 0.1 to the 0.1 is getting closer to 1. And if you do that at 0.0001 to the 0.0001, you're going to see it's really close to 1.
Right. Square root of a half, so 0.5 to the 0.5 is bigger than 0.5.
Right. And so it does grow and gets really close to 1. So in that way, you can kind of convince yourself if you take the limit of x to the x as x goes to 0, it is in fact 1. Which is weird. 0 to the 0th power, 1. There it is.
Weird.
All right,
There it
anyway,
is. Okay.
onward.
Well, our trivia to segue us into our dust topic is a dust trivia.
She's going to redeem herself.
In a few minutes here, we're going to be talking about dust in the cosmos and how much dust the cosmos is shedding on the Earth. So our trivia is about dust shed here on the Earth.
Oh.
First, so of course
I don't
it's a
wanna
multiple.
answer this
It's
trivia.
that's fine. It's
Okay.
not that bad. The dust mite part is maybe a little gross, but so first part is just when was the first vacuum cleaner invented? I'm just going to ask you that right now.
Are there like parameters on what defines vacuum cleaner?
This is a mechanically engineered sucking device. It is not a broom.
Okay.
It's creating a vacuum.
1923.
1937.
1901.
Wow.
But
Wow.
this was a gasoline-powered, horse-drawn contraption,
Weird.
not for indoor use. Yeah.
Yes.
Okay, so your two parts that we'll save for after we talk about cosmic dust is over the course of a year, how much dust in the form of dead skin cells, you knew this was coming, I knew this was coming.
Yeah. Biology
How much
says-
dust in form of dead skin cells does the average person produce in a year?
So much.
You mean a mass?
Yes,
Okay.
what's the mass of the average amount of dead skin cells, which is a significant, but not actually the overwhelming fraction of household dust, but it's a significant fraction of household dust is dead skin cells.
Yeah, we're gross.
Mm-hmm.
We are gross, but you know what's also gross?
A lot of things.
Dust mites.
Dust mites.
And most people say, oh, I'm allergic to dust, are actually allergic to dust mite poop.
Oh.
And in fact, most people who have allergies of any kind, 80% of people with allergies of any kind have allergies to dust mite poop.
What?
And it's the #1 cause of allergic rhinitis, or runny nose, as I like to call it. During its 80-day lifespan, the average dust mite produces about 1,000 particles of allergen waste particles.
Oh, that's not very many.
There are some fun
That's a lot
little
of food per
facts
day.
that I'll give you at the end of the show when we have your answers, but
regular.
your dust mite question is, how many dust mites in 1 gram of dust? So if you dusted your house and collected a gram of household dust, how many dust mites would be in there,
Is this like a standard
invisible to you?
cleanliness measure?
It probably
First one
is.
is how much dust per square foot of your house.
Right.
Number of mites per gram of dust.
Oh, this is
You
good.
probably can't do anything. I mean, unless you're living in a very very arid environment where dust mites can't survive because they absorb their water, they don't drink it.
Oh.
So very arid environments, like out in the desert Southwest, you're not going to find dust mites.
Probably not a lot of dust mites on like station.
Probably not.
There's some gross stories from astronauts about shedding on station.
Gross.
Interesting. Okay, that'll be for future trivia. But how many dust mites in a gram of dust? It's multiple choice. 50, 30, 1,000, 20,000, or 250,000.
Oh my gosh.
Okay, so we'll come back to that with some other fun dust mite facts, but let's talk about cosmic dust.
Okay, that's the kind of dust I like. Sometimes in my talks now, when I give public talks, I have a slide at the beginning that says, "This is the dust I'm talking about, not this
That's
dust."
right.
And
Yeah.
it's like a dusty
That's-
table with
that's
dust
pretty
in
good.
it. Yeah.
Yeah.
I talk about dust and vacuums in my talk, so you know I gotta clarify which
That's
one
right.
I'm talking
Yeah,
about.
yeah.
People think about, oh, they hear about
Vacuum
vacuums.
cleaners.
Yeah.
But you want to put dust in your vacuum cleaner, but you don't want to put dust in a vacuum chamber. But I do.
I saw a local news story in Colorado where the local news anchors were ridiculing the fact that there was a conference on vacuum technology taking place at the Colorado Convention Center.
Oh, because
And
they.
they totally thought it was about vacuum cleaners. Instead, it was about these very high-tech,
Yeah.
very expensive equipment that is used in all sorts of research labs to produce very high-quality vacuum chambers.
Yeah.
that are needed for all
Those are
sorts of
some
research.
Fascinating conferences. You
So-
get some good swag.
Joke was on them, except they
Jokes
didn't know
on you.
it. Alright.
Dust in the universe. So this article is actually about specifically dust in our local environment. So here in our solar system and specifically here on Earth. So we've talked, I think, a few times. And there's articles every now and again about like how much dust is sort of falling in the atmosphere and how we collect it. There was a cool story a couple years ago about dust that had been collected from like rooftops in a city.
Oh, yeah.
They were collecting, and it's really interesting because it's just like falling all the time. It's little micron-sized stuff, like smaller than a hair, sort of the width of a hair, that's falling all over the place all the time. And how much is there, and where does it come from? So one of the cool ways we study space things that come to Earth is by going to Antarctica, because it's this really nice, pristine environment. If there's a nice space rock that fell on the ground, you see it because it's just like snow and ice.
Right.
So the rocks stick out. And also just like over time, there's places where the rocks have gathered and picked up and we can find nice like deposits of meteorites and stuff. But this study that just came out is from a study monitoring at Dome C, Antarctica, accretion of extraterrestrial dust over time here on Earth. So they've actually been studying at the station for 20 years.
So they're seeing the gradual buildup.
Yeah,
They could have just come to mind.
I know, right?
bedroom,
And
right,
watch
yeah.
but just extraterrestrial dust.
Okay,
Only some of your dust is
extraterrestrial, this is true.
So they have this cool, and it's a group of French scientists from a bunch of different agencies, and they not only measure like you can take one sample, but they measure the flux, so the amount of dust over time, and they measure like the particle size distributions down to 30 microns, so really tiny stuff, and they see these studies where they see all different shapes and sizes. They can tell if dust has like melted or didn't melt, like as it came through the atmosphere, and that tells them about like where it's from. So it's pretty cool.
So where is it from?
Space.
What?
So a lot of dust comes sort of at the same time as when you see like a meteorite, right? There you see or a meteor streak, right? Then you see big stuff burn up.
Right.
But when that's happening, there's lots of small stuff falling into. But then every day we just have stuff falling, and it comes from asteroids. It turns out probably something like 80% actually comes from comets.
Okay. So these would be, are they ice?
No, these are all dusty things. I think ice is harder to find in Antarctica.
Yeah, I would think so.
Yeah, so these are all bits of like.
Well, ice would be easy to find in Antarctica,
That's true,
but not
but
extraterrestrial.
It's harder to isolate than it's extraterrestrial. Yeah. No, these are bits of, I don't know, the
silicates or whatever. I mean, comets, we're always like, oh, those are the icy ones, but when we go look at a comet, they're very dark and dirty.
Yes.
Right. They are dirty snowballs, even though the majority of their volume and mass is made up of ice.
Yeah.
There's plenty of other stuff there.
Right.
And part of that's because there is dust mixed in with the ice, so as the really pristine stuff goes off the surface, it's like if you live in a place where there's snow and you have snow build up, and then over time it sort of turns dark.
Yeah.
Due to, in that case, it's due to the fact that you mostly like ash or the sand or whatever left
Right.
mixed over left. But also ice can get darker due to the solar wind effects or solar UV effects.
Right,
So
which
over time-
preferentially removes the sort of ice parts and leaves behind the dark parts.
Yeah.
Yeah.
But this, so this is mostly looking at little rocky bits.
So how much stuff is coming in?
Oh, I forgot to see what that actual number was. It's more than 5,000 tons per year.
5,000 tons of dust particles.
Extraterrestrial dust per year, which is a lot. I feel like, I don't know.
Yeah.
I feel like I should feel that every now and then. It's like with those neutrinos.
Maybe,
They're always there and you don't even notice.
yeah, maybe it's those days where you're just feeling like there's that extra weight on your shoulder. Maybe
Yeah.
that's what it is.
And this is particles that are around 30 to 200 microns in size. So there's more stuff
Small
that's
stuff.
bigger that falls, and they're not counting that. So this is all like really small stuff.
Okay. And so, and presumably maybe there are even smaller particles that they're not able to see.
Mm-hmm.
And
Yeah.
then presumably there are also maybe those icy particles that we're also not able to see. Do they try to factor that in? I mean, if they're saying, okay, 80% of that 5,000 is dirt from comets, and if you figure that the comet is, maybe only 10% of the comet dirt that's coming in is dirt, and the other 90% is ice, maybe
Yeah.
there's 50,000 tons of comet
Material.
water coming in.
Yeah, and that's contributing. So that would probably get stuck, deposited in the atmosphere, kind of, and settle
Yeah.
out differently. I think.
Yeah, but over time, I mean, I'm completely speculating in the blind here,
Mhm.
but one of the big areas of research is understanding the source or origin of water in the Earth's overall budget.
Yeah.
And comets are talked about, we usually think of it as the comet itself, which comes in and hits.
Mhm.
And I'm just curious, I wonder whether the comet debris of water molecules over millions of years is a significant contribution or not.
I don't think that I didn't see that estimate in the article.
Mm.
So I don't know.
You know, who was the right person to ask that question?
Who?
Your wife.
Oh,
That's
my
probably true.
wife.
And if she didn't know, she could ask her thesis advisor.
There you go. They would probably know.
Yeah.
I was
Yeah.
wondering if for next time our trivia question is going to be which the energy impacting the Earth every year, is it more from this dust
Oh,
or
yeah.
neutrinos?
Oh, that's a good question.
Well,
Neutrinos.
what do you mean by?
So there's
impact?
if there's
Because
5,000
most of the energy from the neutrinos is not deposited.
Right,
on the Earth.
That's
right,
true,
it is not.
that's
It is
true.
So are you talking about?
I just mean like the flux through
The energy flux,
The energy
so
flux.
all the neutrinos, not just the ones,
Right.
not the tiny fraction.
right.
actually
Well, that would be
are
almost nothing.
interact.
Right. Yeah.
Yeah, okay. That's gonna be your trivia question
Maybe.
next time.
We'll see.
Well,
For your
that's
next
not-
year. Yeah, the searching for meteorites, so it's like, where do we find meteorites in Antarctica and the Sahara Desert?
Right.
Mhm.
It's like, that's where
The
meteorites
tough
just, they
places.
love to fall.
yeah,
Oh,
right.
Why
There's
do they
a-
always go
Yeah,
there?
why can't they just be in my backyard?
There was one in our backyard recently.
What?
Well, I mean, not in your backyard, but there was a meteorite that was that people saw here in Central Florida recently, and it was captured on our camera at Robinson.
Well, meteor,
really?
not a meteor.
But was the
right?
meteorite
I don't know if
recovered?
it's been recovered yet.
Yeah, it's hard in Florida because there's all this life stuff. going
Yeah,
on.
Yeah.
stupid
Yeah.
vegetation and water. and
Sometimes we
stuff.
find them, but not.
Yeah, but we look in Antarctica and the Sahara for these things precisely for you. Just as like the old joke about the drunk who lost his keys and was looking under the light post, and it's like, where'd you lose your keys? Like, over there. Why are you looking under the light post? Well, the viewing is much better here.
Yeah.
And that's where the viewing for meteorites sites is much better.
Yeah. The other thing to consider, right, is that this is the stuff that they're finding on the ground. There is a lot of stuff that maybe
Just
does size
suspended in the
distribution or
atmosphere.
smaller particles that, yeah, to stay in the atmosphere, burn up,
Right.
etc. So there's more stuff that isn't discovered.
The beginning of the study of interplanetary dust particles involved sticking out little collector plates of goo on the wings of very high altitude, like spy planes,
All right.
in the very upper atmosphere,
That's
above the troposphere.
That's awesome.
And
Yeah.
they would come down and you would see these very fractal micron,
Yeah.
more than micron, but interplanetary dust
It'd be cool
particles.
to do something like that on one of the like blue flights.
It would be.
Oh, looks like we got a proposal to
We got a
make.
proposal.
Open a thing
Yep.
and then close it.
There's
Open
your
it when you're
proposal.
up high and then close
Well,
it.
that seriously has been discussed for those suborbital rockets because
Yeah.
they travel relatively, the
It's much slower
rockets,
than like,
they're traveling slower through that part of the atmosphere
yeah.
than the rockets that are heading to orbit.
Right.
They're
Right. They
going
just
all out
right.
to get
And even
home
like
as fast as
sounding
possible.
rockets that have been used for doing
Are
some
also-
like
yeah.
suborbital stuff, they're traveling much faster
faster,
usually than
yeah.
these. So it's-
Okay, but I don't know if anybody's actually done that yet. Well, this brings us back to our dust mites.
Does
Great.
nice.
Yes.
So excited.
So, how many dust mites, number of dust mites, in a gram of household dust on average? Your
I've got
choices
the
are,
first question was how much stuff?
how much dust in the form of dead skin cells, kilograms, does a person produce in a year? And then the dust mite question. So we'll do the, how much dust are you making to help feed all those dust mites?
100 grams.
100 grams?
100 grams.
He said in kilograms.
He did say 0.1 kilograms. I'm
Okay.
sorry.
That's
I'm
fine.
gonna say I'm gonna say 0.6 kilograms.
It's Addy for the win. There's
Nice.
a range of answers, but they sort of range from like 0.3 to a couple
Oh.
kilograms of dead skin per year. Adds up over the course of your lifetime.
Yeah. How come I'm not losing weight then? Come on.
Yeah.
You need to start getting rid of some more dead skin
Yeah,
there.
exfoliate more, Jim.
Yeah.
Yes, yeah. So that's plenty of grams. That's hundreds of grams,
Hundreds of grams.
maybe even 1,000.
Oh god,
grams.
now we're gonna multiply.
And each one of those
Oh, my
grams
God.
of dust, if you could scoop it up, of dead skin cells,
Don't do it.
the dust mites would be hanging out.
I'm
And
gonna
assuming
test
you're
this.
living in
How
an
big are dust
environment,
mites?
Well, you
they're
can't know
pretty
that.
small.
How many microns?
No, you can't tell. That's going to give you the answers.
Oh, I'll look up after then.
Yeah. So 50, 300, 1,000, 20,000, or 250,000
Per gram.
per gram of dust, of household dust.
300.
1,000 was that an option?
It was.
That's the one I want.
Abby's right
I
again.
don't want it.
She
but
knows her
she's-
dust. She's established herself as the dust expert
Yeah.
here.
Should have dust. That's right.
One interesting.
They're like on the order of less than a millimeter.
They're smaller than tardigrades, but not as small as I would like them to
A
be.
quarter of a millimeter ish.
That's still too big. That's way too big.
Yeah.
That's 250 microns.
They're all over the place.
The weight of the average mattress, I
Oh, I'm not gonna listen to this trivia.
read,
When you buy it
Dust-
and then at the end.
yes,
Oh no.
because of dust mite infestation. So here's an experiment for a citizen science experiment for all of our listeners.
Weigh your mattress.
Get a
when you
new
buy
pillow,
it.
still with a pillow.
Okay.
Buy a new pillow,
That's
weigh
forward.
it, and then weigh it monthly for a year.
But how do you account for like oils and stuff like that too?
Uh,
Are you washing it in this time?
no.
Oh, okay.
So use a pillow
This is a
for a
gross
year.
citizen science
Use a
project.
pillow for a year. Some sources say that the mass of that, of course, it depends on what the pillow is made of.
Sure, yeah.
But you should see a noticeable increase in it due to dust mite poop,
Mhm.
which will make you sneeze or throw up,
So
apparently.
I just I don't like picturing that.
I know. And dust mites
How
are,
big is dust mite poop?
it's small. It's really, it
Small.
breaks down. It's not like, it's not like poop. I'm saying poop is whatever their waste
Excrement.
products are, right? It's proteins.
This is the
It's the
astronomy
proteins
podcast.
that we're
Let's
allergic to.
pivot back.
Yeah, okay,
I'm just-
yeah.
Math, biology,
But
astronomy,
actually-
we do it all.
I actually
Yeah,
am
well
curious
covered.
if there's been studies of like dust mite populations on station now. I bet there have
I
been.
bet there
People
have been
study
as
all
well.
that kind of stuff.
Yeah. Well, While it may have felt like listening to a really terrible singer try to sing,
Only at the beginning.
it was just another episode of Walk About the Galaxy. Write us a review in the form of a hit pop song. Since it's a hit, that should take care of it. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walk About the Galaxy, where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Drusik. Thanks to our listeners in Michigan and around the world. Stay safe. I'm Hugh Jackman.
I'm Lucy Lawless.
And I'm Dolph Lundgren.
We're the Astrocorp, signing off until the next episode of Walk About the Galaxy.
Dust mite feces are about 20 microns.
Really?
Yeah.
That's too
Same
big
size as
too.
the dust we found in Antarctica.
That's too big.
Space dust.